Okay, perfect. All right, well, I am going to get started then. Hello, everyone. Um, Today we're going to be talking about intelligence, artificial, generative, whatever. My name is Mark Takata. I'm the Senior Technical ColdFusion Evangelist at Adobe for Adobe ColdFusion, which, of course, everybody knows about. And if you don't, come see me. Today, we're going to be doing an overview of artificial intelligence, and there's a lot to cover in here. So we're going to do an intro. We're going to talk about what intelligence actually is, not just in computing, but in general. Early concepts and theories of AI, the birth of generative AI, which is the reason why you are all probably here today, because AI has been around for a really, really long time. Generative AI, not so much. It's very, very brand new. We're going to talk about the evolution of those generative AI models, AI in the 21st century in general, generative AI in modern applications, some of the tech breakthroughs that have led to, Gen AI basically taking over the world, Gesundheit. And we're going to do an overview of 3 current generative AI models and talk about the future of AI a little bit. But first, who the hell am I? Like I said, I'm Mark Takata. I'm a programmer with over 25 years of industry experience. I have professional experience in 14 different programming languages and frameworks. I'm a designer, a painter, a VR and augmented reality enthusiast, keynote speaker. I do a lot of running, long distance running. Not currently, because I hurt my Achilles tripping over a box. Yeah. And I play a lot of video games really horribly. All right, let's dive into an introduction to artificial intelligence. So what is artificial intelligence, just to begin with, right? Like, what is it? So it's a simulation of human intelligence in machines that are programmed to think and learn. And those two words, think and learn, are very loaded. I'm going to be using a lot of words that are very loaded because the reality behind what's actually happening on the machines has nothing to do with thought necessarily, right? And it's a big mistake that people make when they think about artificial intelligence as being alive. It's actually very problematic. Now, the things that most people have interacted with prior to things like ChatGPT were chatbots, personal assistants, right? So Siri, Alexa, and those actually did use AI. They were using AI to understand human speech and be able to understand contextually what we were asking them, and then respond to that and do a series of things. Now, generative AI is a subfield of AI in general, and it focuses primarily, and I'm going to cover this over and over again because it's really, a lot of people just don't get it, on creating new content, right? Taking learning sets and making something completely novel from that, whether it's text, images, music, or even contextual understanding. Okay. That's different from the other AI forms, which typically analyze or interpret existing data sets, no matter how big they might be. So like a regular AI, you could give it a photograph and it'll say, there's a cat there, right? Generative AI would create an image of a cat that had never existed before. So here's a little bit of history, and this might surprise you, but the history of AI goes way back. Right. In the 1950s, there was something published called Computing, Machinery, and Intelligence by a guy you might have heard of, Alan Turing. And this was actually where the Turing test was first proposed. And it's a method for determining if a machine can actually exhibit human-like intelligence. Essentially, you have a computer or a person, you can't tell when you're on the other side of the wall, responding to questions. If you can't tell that the answers to those questions are coming from a computer, it passes the Turing test. Now, of course, many, many, many years later, we've realized that's probably not really the gold standard of how you should determine whether something is actually intelligent. But at the time, it was all that we had. And at the time, it was a breakthrough in understanding what AI might be. Now, later in the 1960s, the ELIZA program was developed at MIT by a guy named Joseph Weizenbaum. And it was one of the first times when natural language processing was first starting to become understood. And a lot of you have probably interacted with ELIZA bots, and you probably laugh thinking about that as an artificial intelligence because, of course, the way that it responds to you is very simplistic. It takes what you say and factors it essentially into like a question or something like that. But the underlying technology there was very novel at the time. The ability to understand which parts of a sentence were which and then recombine them as an answer was actually really, it was a breakthrough. In the 1980s, we really had a big breakthrough in algorithms, right? So backpropagation was something that came about. Rumelhart, Hinton, and Williams, they revolutionized neural networks, and they really they laid the groundwork for what would eventually become the thing known as deep learning. And deep learning is probably the first time when AI really began to deeply impact society as a whole, mostly from just stories that we were hearing, specifically Deep Blue. So Deep Blue was a computer, and it's very famous for beating Garry Kasparov at chess. Now, for those that don't know, Garry Kasparov was a phenom in chess. He was the world champion for a very long time, extremely good at chess. And this was a little bit of a big deal at the time because nobody really thought that a computer could beat Garry Kasparov. And it did, handily. Right. Now, of course, if you think about what chess really is, there's a finite number of chess moves and a finite number of ways to win at chess. Now, that number, while finite, is exceedingly high, but computers are really good at big numbers, right? So once we got to computing power that could calculate that, fortunately, Garry didn't really stand a chance, right? Now, that moved into the 2000s and beyond and into the current era, and it really didn't start to wind up until about the 2010s when in 2014 Google acquired DeepMind and created something called AlphaGo. And AlphaGo was famous for defeating the current, at the time, human champion in the game of Go, which again was, people didn't really think that you could create a computer that could beat someone at Go. It's a little bit more complex. They say it requires creativity, but the computer did it, and again, did it quite handily. And it really showed off the power of deep learning and neural networks and what it could do at the time. Now, of course, fast forward another 6 to 8 years, and the advancements in generative AI have completely taken the world by storm. GPT-3 and others really demonstrated the AI's growing capability in understanding and generating human language, music, art, and way more. Oops, wow. I'm sorry. Okay, but let's back up a second and really talk about what is intelligence, right? We talk about artificial intelligence a lot here, right? But what is it, right? Is it, is it your SAT score? Is it your IQ? Like, we've determined fairly solidly that those things are not necessarily great indicators of intelligence in general. But we can talk about intelligence in a number of ways. And humans, when we talk about it, it's things like learning from experiences that you have, adapting to new situations, understanding and handling abstract concepts, using knowledge to manipulate one's environment, likely for your own benefit, of course, right? In machines, it's thought, we think about it a little bit different. It's the capability to do mathematical computations, algorithms, the ability to go through extremely large data sets and pull data back out. That's really what we think about when we talk about intelligence in machines. And it's all about programming and rule sets and rote, right? That's the way that intelligence in machines was thought of prior to this new sort of generative AI concept that's come out. And I'm going to give you a little bit of a metaphor here to talk about the different kinds of intelligence and how you can apply them to computers and people. Let's talk about car mechanics. We all have cars. All of them are broken down. We've probably taken them to a mechanic once or twice in our lives, probably a lot more than that, right? We all know there's different levels of mechanics out there, right? At the low end, we've got the screw ups, right? We've got the guy who fixes one problem and breaks 5 other things in your motor, right? He cuts the wire to get to the screw that he needs to tighten on your car. Those are the people that you really never want to take your car to. Low intelligence. In computing, it might be, an algorithm that always gives you the wrong answer every single time, right? So we throw that out. But next up, we have the mechanic who is really good at following the manual. right? You have to swap, the head gasket on your car. Well, there's a set of steps in a manual that you can follow to do that every single time. And these mechanics are extremely good at it. This is a form of intelligence, the ability to understand rules and follow them very closely as applied to a particular thing that you're doing is a form of intelligence. And this is also the type of intelligence that things like Siri and Alexa were extremely good at. They were very good at doing the things they were programmed to do, following orders, basically. They were really good at that. Search engines as well, right? You were able to return back the data that you were asking for, and it would do it pretty much the same and really, really well every single time. Now, you move that up a step, and you get applied intelligence. So this is the mechanic that you bring your car to and you tell them, oh yeah, like at 3,500 RPM on the freeway, there's this weird whistling noise and the power seems to have a flat spot in it. And the guy says, oh, well, it seems like there's probably a broken hose near your turbo, right? And it's when the turbo spools up, it's actually a leak and it's creating this flat spot. And you go, there's no way you could possibly know that. How would you know that? You didn't even look at the car. But he goes in there and sure enough, the hose is broken. And he fixes it, and the problem goes away, right? Didn't have to look at a manual, didn't have to plug it into their little machine to check what it is. They just have the ability to take their incredibly large data set that they have from working in the industry for decades and apply it to the task at hand, right? They knew that your car was a turbo just by looking at it. They knew that turbos spool up at a certain RPM, that could be a problem. And so they inferred what the thing was. Now, this is what AI has been for a really long time. Let's take it a step further. There are mechanics out there who are incredibly good at taking completely novel things. You could hand them an engine that they've never seen before in their entire lives, V16 quad turbo or something that runs on avgas, right? Something they've never worked on before. And their understanding of how engines work, the physics behind it, the engineering principles are so good, they would be able to fix whatever is wrong with it without ever having seen it before, without ever having worked on it before, and maybe even improve it. Those people are extremely rare, but they are the people who are able to take their incredibly large data sets and create new and novel solutions in context, sort of, but even expanding that context out, right? And there's very few of these people. The only one I can think of is like Ant Anstead. Like, this is a guy who knows so much about cars, he can build one from scratch and make it work and raceable the very first time, right? He understands suspensions, transmissions, engines, everything, right? That's generative AI. That is what generative AI is. It takes these incredibly large data sets and is able to create new and novel, contextually relevant and brilliant answers for us. Now, you might be thinking, should I be worried about my job? Should I be worried about, like, are they going to replace us? Well, I have some answers, and they may or may not make you feel good. So Niels Bohr, who was a physicist that worked in quantum mechanics, once famously said, if quantum mechanics hasn't profoundly shocked you, you haven't understood it yet, okay? And unfortunately, generative AI is sort of in that vein. We don't actually understand necessarily everything that generative AI does or why it does it or how it does it. Occasionally, there are emergent properties in generative AI that we don't program in, which is a little bit scary, right? But here's some good numbers for you. There are 86 billion, with a B, neurons in the human brain. They create 100 trillion synaptic connections, okay? Trillion with a T. That number is so vastly big, it's basically impossible for the human mind to wrap its arms around. 100 trillion is an insanely, insanely large number. The best and most powerful AI today, and now next week this might not be true, actually tomorrow it might not be true, but today, Gemini Ultra from Google is rumored to have, I don't know the exact answer, but I think this is probably pretty close, 550 billion parameters that can be mapped over to neurons. Uh-oh, that's a problem, right? We have 86 billion neurons. It has 550 billion parameters. However, it's also rumored to have only 10 trillion connections, which can be mapped over onto synaptic connections in the human brain. So we have 10 times as many as the currently most powerful AI in the world. And that's all being done in something the size of a cantaloupe. Well, bigger or smaller, depending on who you are. And while Gemini doesn't fill buildings like computers used to, it's definitely not this small. Distance matters when you're talking about billions and billions of calculations every second. So yeah, we're still up on AI, but maybe not for too much longer because it's only taken us a few years to get here. So let's talk about some early concepts and theories of AI and really where we came from and where we're going. So as I mentioned before, the Turing test in the beginning came about. And neural networks were actually around in the 40s, right? And artificial intelligence, the word was coined in 1956 by John McCarthy at the Dartmouth conference, right? So these things have been around. In fact, in 1955, there was a program written, which is generally thought to be the very first AI program called The Logic Theorist. Now, moving into the 60s, we had this huge hype roller coaster, which is, and I'm telling you about this right now because a lot of people are saying we're going to be in this sort of thing again, right? People are excited, people are throwing money at it, hand over fist, and that was happening in 1967. AI was thought to be the big thing. So Marvin Minsky in 1967 said, "We are one generation away from all of the problems in AI essentially being solved." Now, spoiler alert, in 1987, generation is usually thought of as 20 years. 1987, we did not solve those. Neither did we solve that in 2007 or 2017. 2027, we'll see. But they ran into some really major problems. They didn't have the computational power to actually create these really powerful algorithms. They didn't have the ability to store the incredibly large data sets that they needed, or even get the data back in any sort of fast way. And the algorithms they were using to actually get that data back were kind of simplistic. We had not developed the mathematics that we needed to get where we are today. And at the time, that created something called the AI winter. Money sort of dried up, and people began to think about AI as an unsolvable problem. In just a decade or two, it went from being the hottest thing anywhere to maybe this isn't a thing that's going to happen. Now, a lot of you who are in tech are like nodding your heads because you're like, oh yeah, this happens every few years, right? The last one was VR. People are saying this is going to happen again in AI. So we'll see. But it's a little bit different today. We have better algorithms. Our algorithms are actually very advanced. We've started creating these incredibly large data sets, billions upon billions and trillions of different pieces of data that we can train these models on, which is incredibly important for building strong AIs. And getting that data back has never been faster. We've created these huge leaps forward in computational power, even creating custom chips for getting this data back. And a lot of it is happening in the cloud, which is essentially almost unlimited, right? You can keep turning that dial, and as long as your wallet is fat enough, you will keep getting more and more power out of that nozzle, right? But the big thing that happened that really had not happened in the 60s, and what I feel is going to drive this revolution forward and just never, ever stop, is that we began seeing consumer products powered by AI making money. And that's really, at the end of the day, what ends up driving all of these things. If there is a market for it and it makes money, people will put more money into it to try to continue to create that consumer-driven marketplace. And that's happening right now in a huge way. So, okay, so that's AI in general. What about generative AI? Right. So as I mentioned before, generative AI is focused on creating new data that resembles in some way, but is different from the training data. It's not just interpreting that data. It can be in the form of text, images, sounds, music, other media, code. It can create realistic images of people who don't exist, or compose music in the style of a certain composer, right? So where did that all start? Now, some of you who are into finance or insurance or anything like that might be familiar with Markov models. And Markov models were sort of the nascent beginnings of what generative AI came from. And essentially, what a Markov model does is it takes a word or a number or a thing and tries to determine the likelihood of what the next thing in the row will be. And I love that this is like one of my favorite definitions ever because it's like such a mouthful. A Markov chain or a Markov process is a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. Informally, this may be thought of as what happens next depends only on the state of affairs now. Oh my God, there's the math, right? So this is all statistics that we're talking about, but that's really what underlies a lot, well, actually all of generative AI is statistically determining what that next pixel needs to look like, what that next word needs to look like, what the next phrase needs to look like in context with everything around it, right? And that started off not only in making like simple coherent sentences, but also in generating some images like dogs and cats that had never been seen before, or even people's faces, which I remember when that happened and everybody freaked out, right? Oh my gosh, this thing can create people that have never been around ever. And everyone sort of panicked because I don't know why. Because you could like create faces that had never been around. But even before that, we were doing things like generating textures in video games very, very easily because we could tell the computer what we wanted. And based on mathematics and things like Markov chains, it could figure out, well, the texture on a tree probably looks like this. And it could generate them for us instead of an artist sitting there going pixel by pixel and drawing them, right? And then came the big one, the daddy of them all, ChatGPT. I think probably everyone here has used ChatGPT. Most of you probably have an account with them. I know I still do. And I literally work for a company that makes an AI, which I will not be talking about today. Cough. So lawyers, back off. ChatGPT was really the thing. It was the spark that lit the fire of generative AI. It became something that you or I or anybody could go and use very easily, fairly cheaply. They had a free model for a while. It was something that gave back usable answers and was super useful. And we went from essentially 0% of businesses, nobody using AI, to 77% as of 2023 of businesses using AI. That's from November 2022. Okay, that is absolutely mind-boggling of a movement, right? There's very, very few things that have done that in the past. I mean, cell phones took longer than that, right? Everybody now has a cell phone. When I was a kid, nobody had cell phones. It didn't exist, right? Maybe some rich guy in a Mercedes had, a car phone that they called it back then, right? Encryption on the web was another thing, right? It allowed people to have e-commerce, and now everything is e-commerce, or maybe even the web itself. Like this is that big, but even all of those things didn't happen as fast and didn't have the adoption that ChatGPT and GPTs have had in the generative AI space. Right, so where are we going? What are the things that are going to be next? So I'm going to talk a little bit about that on the last slide, but really the things that are going to drive us forward are more data, right? These things are hungry for data. The more data you have, everything else being equivalent, the better the AI. That's just the way that they work. The faster your computing power, the faster you get that data back. Also, very, very important. You don't want to be waiting minutes or even several seconds for an answer. You just want it to come back immediately. Multimodal approaches, and I'll talk about that specifically with one of the models that's out there. And what I mean by that is usually when we think of these generative AIs, we think about either a text model or something that makes music or something that creates an image. We'll go to Midjourney and create elves or whatever, dancing, frolicking through a forest or whatever you want to do. So multimodal approaches take multiple inputs and use those to both train and get answers from an AI. So for example, you could put in a bunch of images, like a PDF that had both images and text in it, for example, and it could look into the images, understand what they're of, as well as reading through the text and understanding the text and using all of that as training. That's a fairly novel thing. It's very, very new. Currently, I'm only aware of one model that does that, but I feel very strongly that that is the very next step that people are going to, because this AI kicks the butt of pretty much everybody else due to this capability. And there's going to be a movement towards more general versus niche AIs. Now, what do I mean by that, right? So if you think about AI in science fiction, in movies and things like that, it's never something that does one thing, right? That there's not an AI that creates marketing text for you that's going to take over the world. It's probably something like Ultron, like that is capable of creating new bodies for itself and taking over computers and renting cars and, making cakes. I don't know. Like, it's capable of basically everything that a human being can, plus, plus, right? It's way smarter than us and way faster at the things that it does, except for the ethics, right? Although one might argue that, I mean, humanity hasn't been too nice to the planet, so getting rid of us probably would make the planet better in its eyes. I don't know. That seems slightly over dramatic of a response. But yeah, that type of AI doesn't exist. We've never come even close to having something that can do everything, just because of the difficulty of creating that, right? 100 trillion connections in the human brain, right? We're only at a tenth of that right now. But of course, we've gotten to that 1/10 in just a few decades. So we may be heading that way. Another thing that could potentially give us the same effect as a general AI are things called AI agents. And me and Rick were just talking about it a little bit earlier, but essentially these are things that are able to interact with other AIs, and I'll go into that at the end when I get to the last slide here. So let's talk about three models, three approaches to AI. So the first one is something called a GPT, and you're going to see the term transformer a lot. That's a little bit out of scope for this talk. If you're interested in learning how a transformer actually works and what it does in a GPT style of AI, please attend my talk. It's going to be happening in a few weeks at the online ColdFusion Summit. Rick can probably get you a link to that. But a GPT stands for Generative Pre-trained Transformer. So this is usually something that generates text that is coherent. It's human-like. It's useful for things like writing assistance, content generation, and even programming. And what's interesting is these are the AIs that are most likely to make people think that they're alive, which is a big mistake. AIs are not alive, not even close. They're just math. But they're real good at faking it. It's convinced more than one person that it was actually some kind of sentient being that's sitting at the other end doing something, right? They're not that. They are very good at generating marketing text and being chatbots, helping you with your programming, your coding. Although, again, as me and Rick were mentioning earlier, sometimes that code that comes out maybe isn't the best. Sometimes it doesn't work. So you have to be really careful about what you're getting back from these, but they are getting better over time. And there are a lot of a lot of guardrails are being put in place slowly to try and help prevent some of these so-called hallucinations or mistakes that are coming out of GPTs that are out there. But as I said before, 77% of businesses are using some form of AI right now, and that's for things like customer service, programming, sales, marketing, and as well using some of these other AIs that I'm going to talk about now. So BERT is probably something that you have never heard of. So it's something that you will generally not interact with directly, and it's definitely not as fuzzy and cute as ChatGPT. Right, so BERT is a bidirectional encoder representation from a transformer, and it's sort of a backwards, reversed version of ChatGPT. It's really incredibly good at understanding inputs, right? So you put an input in, you're asking it to go and look up a series of things, let's say, right? It's extremely good at understanding what you actually mean when you say that. So it gets nuance, and it's often used to retrieve data. Um, and this is a really good thing. If all the data that you got back was just simply just the word that you were looking for, you would probably not get all the results that you want. BERTs have been around for a long time. You might notice Google, our favorite search engine out there, and even Bing and others, they use a form of BERT to make sure that when you ask for football, right, or whatever, a player, it knows what you're talking about. It's not a record player, right? It's not a ball that looks like a foot or something. It understands contextually not only the thing, but things that are around it, adjacent to it, related to it, and then it returns those results in concert with the main results that it got just from the actual text itself. This is super useful for a lot of things. Sentiment analysis is actually a really big thing that this is used for, right? So if you're on social media and you are getting millions and millions of people talking about your product or your company on there, it's impossible to just go through all of them at the same time. These engines can actually go through and understand the underlying emotional sentiment behind the words that are being used in these social media posts and help you determine, like, hey, you guys kind of screwed up. People are extremely mad at you, or people really loved what you did with the ad that had the kitten surfing, right? That was great. Like you're now you're moving forward in that. Use that, leverage that, right? It's a really powerful ability that you wouldn't otherwise have, because it's really hard to get there in literally any other way. And the other thing that's really good for is language translation. Anybody here who speaks multiple languages knows they don't map across to each other one to one, right? Sometimes words that seemingly are pretty close in one language, they don't really match up perfectly, right? You want to make sure that you transmit the nuance of what you're trying to say, not necessarily translate it straight across, or else you have I don't know, a 1980s sitcom comedy or something, right? And so BERTs are very useful for anything having to do with the web, right? Because we're dealing with a global community, so we want to be able to speak to them in a multitude of ways through communication, marketing and sales, social media, as I mentioned before. Then the last one is something called DALL-E, which I think they pushed it a little bit with that. It's a deep learning algorithm for image generation. And DALL-E is a little bit famous for having some ethical problems about where you're getting your training data from, because generally speaking, a lot of DALL-E comes from very creative sources, people's drawings, photographs, pictures, that sort of thing. And a lot of them were used as training data without asking first. So you may or may not agree with that as benefiting humanity. I don't know. I'm not gonna comment on it. But what DALL-E is great at doing is generating images that are novel, right? And this also is very hard for people to understand, because the way that it does this, the way that it learns the images and what they're made up of, doesn't make sense to most human brains. And I actually go into some of the mathematics behind it. In how it trains on an image and gets that data back to itself for use in generating new images. But essentially, it progressively destroys an image and figures out how to get it back to the original image over and over and over again until it learns what makes that image up and is able to create images based on that are different and novel. So, anywho, it's also really good at taking your text inputs and creating images out of that, depending on how good your prompting is. Prompt engineering is a whole new ball game out there if you're looking for a new job. I hear those pay really, really well if you're good at it. And it's good for creating things like art, like graphic design, sketching, brainstorming new stuff. I know like tattoo artists that I know use it to create a bunch of sketches of ideas that they might have, and then they use those to draw their own stuff. But they can create something in a multitude of different angles extremely quickly, so it helps them with their workflows and processes. You can also use it to create some basic content if you're just putting out like a little bit of marketing or social media posts and things like that. So it's good for marketing, art, design, sales, right? If you're not an artist, it can help you sort of get around that. All right. We're going to talk about specifically a really, really big new model that's out there, a product called Gemini. And I mentioned it a little bit earlier. And this is an entirely new way of thinking about how generative AI works. Okay. Now, each of the different individual pieces has existed before, right? We've had AI that was trained on music, you had AI that was trained on images, text, books, poems, things like that, right? But Google Gemini is different in that it is capable of understanding multiple inputs at once and learning from them all at the same time. And that's a game changer for how AI works, primarily because that's how human beings work. That's how our brains work. We very rarely learn just in one mode, right? We learn from hearing people talk about stuff. We learn by reading, by seeing pictures, by seeing video, right? By watching someone else do a bunch of things, listening to them talk, right? And that was the thinking behind the creation of Gemini. It's been pretty darn effective. It's a much more human-like understanding capability, and it actually works. This has been proven. Like they've tested it against a lot of the other AIs out there. It kicks butt at a lot of different tests for things like reasoning, math, data retrieval, and other similar things. Now, this is available from Google using Vertex AI. So Vertex AI is not a product, it's like a marketplace inside of Google, and they offer a multitude of different models out there, right? They offer things like Bison, there's things for code, there's more simplistic AIs. Bard was on there for a little bit. And they allow for safety in your data. What do I mean? What do I mean by that? So one of the biggest problems early on was that people didn't understand that when they were putting their own data into AI, some AIs were using that to train itself, right? And very famously, some engineers from Samsung put in some of their code, which was proprietary, and that ended up in the learning data of the AI that they were using, which someone else saw, and they were able to use that code, and people were fired out of cannons into suns. So what Google allows you to do is to train your own data inside of its own little world while still being able to use some of the underlying capabilities of the generative AI, like understanding contextual stuff, being able to talk in a series, conversationally, that sort of thing. It runs on Google's TPUs. So they are actually creating hardware specific to running generative AI, which I mentioned earlier was one of the big steps forward that's going to have to happen if AI is supposed to go to move forward. Tensor processing units is what they're calling them, and they allow you to train models really, really, really fast for all levels of different businesses, no matter how big or small you are. It also comes in three different strengths, I guess, is the way to think about it. So there's something called Gemini Nano, and Gemini Nano is an on-device AI. So this is not running in the cloud. You don't have to have an always-on connection for it. It can run on a phone. It can run on a device on your desk. It's fairly small. It's not quite at the same strength, obviously, as some of the other ones, but it's pretty darn good. There's Pro, which is more basic. It's the consumer model. It's usable across a very wide variety of tasks. And then you have Ultra, which is the big one, as I mentioned, 10 trillion different connections in it. It's very, very powerful and capable of doing some pretty frighteningly good stuff. But it's also extremely expensive. And that's something that you need to really know about AI and using it in business is the costs can really, really, really add up very, very quickly. And it's important if you've got a startup idea that you understand which is the appropriate AI to use based on the cost model that you need. Don't use a nuclear weapon to knock in a nail, right? You're just going to make a big mess and mostly in your financial interest. So what can we expect in the future? So I mentioned earlier AI agents, and I want to get a little bit deeper into really what those are, because this is an area that people have not really explored yet, but it keeps getting talked about. What is an AI agent? Well, it's what Alexa wishes she was, basically. An AI agent is something that's incredibly good at interacting with a human being, understanding contextually what they want, and then taking that and interfacing and integrating into another wide range of other AIs that can then do the task. So to give you an example, let's say I want to rent a limo, have flowers and candy in the limo, and have that limo drive me to this, 4-star restaurant, and make reservations on, the 14th at 5 p.m. Let's say I want that. So I tell my agent to do that. The agent would then know contextually where to go for each of those things, and it would complete all of those tasks, be able to pay for them, schedule them, get things delivered, check on them, make sure that everything happened. Now, that does not exist today, but it's coming. There are companies that are working on this today to make these incredibly intelligent agents that are either in a little, pin that you have on your body or on your phone or in your glasses or on your ear set, whatever, that are always connected to the internet. They're always able to interact with all these things, and are smart enough to just contextually always be in the moment. That's something that Alexa and other things don't have. Alexa can do the thing you ask it to do, and then that's it. It doesn't really have that staying power. It doesn't have that ability to continue to do the thing until it's done, or check on it, or do debugging, or anything like that. She's actually very, very simplistic. As I mentioned before, there's a movement towards general AI, right? And agents feel more like general AI, and it may be that what we end up doing to get to general AI is integrating these hub points that act as agents, and then tying in other models that do the things that we want them to do. Now, I will say, though, that's been tried before, and it's failed because there's a nearly infinite number of things that you can do. And if all you do is build things that do one thing, well, you'll be doing it for an infinite length of time, right? You need something that is flexible enough to be able to do all of these things without having a specific purpose built into it, like a human being, right? So we'll see how that goes. Another big deal is integration with quantum computing platforms. Now, that's probably a term you haven't heard for a few years because it's gone a little bit quiet. And this was definitely on the hype cycle. People were getting super excited. We're going to be able to break all encryption ever done in the entire world. And then what? Nothing. Kind of disappeared. Well, we ran into some of the same problems that we ran into with AI in the 60s. Computationally, it's extremely hard to build computers that work in the quantum realm. It's just really hard. Like you have to be extremely precise for one thing, and reading the things is really hard. They do exist. Quantum computers do exist, and there are people using them. They're just insanely expensive and not super useful yet. But knowing humanity, it's gonna just take us a little bit of time to get there. We're gonna figure it out. And once you combine quantum computing, which creates incredibly, incredibly fast computational abilities, with AI that requires extremely fast computational abilities, look out. that may be that point at which AI overtakes us. Because at that point, things like synaptic connections, they don't really matter anymore, right? Because you can do a nearly infinite number of things all at once with quantum bits. And this is one that's near and dear to my heart. So combining AI with augmented reality, right? This one actually speaks a little bit to AI agents, because eventually all of us will have glasses that look just like this, not like a big stupid thing on our head like we have now from Apple. Sorry, all my friends who work at Apple, but those things are silly. And anyone who's walking around on the street with them looks silly today. I don't care if you're playing Pac-Man while walking down the street, you look ridiculous. But it won't be that way forever. Eventually, we'll figure out how to miniaturize things and put them just into our eyeglasses. And I won't need this monitor that I'm staring at right now, reading this stuff. It'll just be floating in the air in front of me. And I could be doing that while walking down the street. Combine that with an AI agent, and now you're really cooking. Because I could be walking down to the market and ask my AI agent to order my list of groceries and have it waiting for me when I get there. Because maybe I want to pick up a coffee and I want to get a walk-in, right, instead of getting it delivered. Things like that. I could be walking by a store and my AI knows that I need a new pair of pants because all the ones that I have are silly and I need a less silly pair. And they sell less silly pants and they're on sale. And it might tell me, hey, Mark, look over there. There's a pair of pants on sale. They have your size because it knows my size, right? It's a nearly endless amount of partially creepy, I admit, but also extremely useful things that this could do for humanity. It's a personalization AI scale. And that goes from everything from marketing and sales to lifestyle to medicine, right? An AI would be able to understand your healthcare needs far better than any individual doctor. Because let's face it, they're overworked, right? Our healthcare system, no matter where you are in the world, is overworked, especially here in the United States. And an AI could specialize in just watching you. It could keep an eye on your heart rate. It could keep an eye on your blood pressure, what you eat every day, how much exercise you get. It could track all of those things and realize, hey, you might want to do a little bit more exercise and maybe eat more vegetables and do this and do that. And I'm a little bit worried because your resting state heart rate is up about 5 points. Now, my watch does that for me already, right? Yours probably does too if you have an Apple Watch. But combined with all of the other things, it could mean an entirely new way to keep people healthy long into the future. Well, that's it. That is my talk. Thank you very much for having me here. My name is Mark Takata. You can reach me if you'd like to chat at takata@adobe.com. Please feel free to add me on LinkedIn. I'd be happy to add any or all of you and chat on there as well. I am on the CFML Slack as well. And you can also find me on the CFML Programmers channel on Facebook. All right. Over to you, Randy or Rick.
Yeah. Well, I know you don't have a lot of time left, so we kind of want to get all the questions that we can get in. You've got a hard break, you got to leave. So go forth, group. What do you want to ask him?
Let me know. Let me know.
I know you do. You can put it.
I can try and answer. I could try to answer everything, except for anything having to do with Firefly. I apologize ahead of time. I am not cleared to talk about my own AI. Sorry. I can talk about other people's. Yeah, I know. Welcome to corporate world. It's cool. I can say that. I can say Firefly is cool because it is.
Anybody questions? Let me see here. We got somebody.
So I guess I'll start off here with a little bit. One of the areas I do some research on is more on the AI ethics, like policy and law. So that's
a really big area. Yeah.
Yeah. So with as we're starting to get to some of the general AI and all that type of stuff, I mean, one of the big issues that particularly policy people are running into with like generative AI and some of the other ones is the training of the data and utilizing the data and not essentially like sourcing it and all that stuff because they're, boiling it down to tags and all the other stuff. Where do you see like the generative AI kind of addressing some of that, or like where do you, because from what I understand, it's not exactly like the same type of technology where it's consuming data to bring into that.
You're exactly right. It's a gray area, and it's actually been a really sort of, it's been a thing that people are worried about. And I can say this about Adobe's use of ethical AI. I have enough leeway. Hopefully, I may disappear if I just suddenly disappear, then the ninjas got me from Adobe. But that was one of the big deals about Firefly, was that we tried to put in a lot of guardrails in how we used our training data. We used data that we owned. We used data that we had the rights to. Now, some of the people that gave those rights to us maybe felt a little bit unhappy about it, but whatever. We'll deal with that if they ever bring it to court. But at least we had some guardrails in place. A lot of others didn't at all. They just literally took a vacuum to the internet and sucked up whatever they could possibly get. That meant often, because as I mentioned, the bigger the data set, the better the AI, that their AI started off a lot better. And if you remember when Firefly first came out, it was just okay, right? Because we just didn't have the amount of data that these people who were basically unethically taking whatever they could possibly get their hands on and training their stuff. Now, if you've used Firefly recently, you'll notice, hey, it's pretty darn good. It's actually, I would say, probably at parity with some of the other ones that are out there. And it's just taken us enough time. But the difference is we actually sell usage of Firefly to very large corporations because they trust that they will get indemnification from us for our usage of the training data the proper way. You are not going to see that with something like Midjourney. If a big corporation were to go in and actually use that in one of their products, it would be extremely problematic, right? We've already seen lawsuits that came out from artists, for example, that are upset that people are able to generate these types of things that look exactly like their art, because, spoiler alert, it was trained on their art, right? And they're upset about that, and I would say rightfully so, right? Now, that was years and years ago. That was in ancient times, in 2021. Forever, I barely remember it. Today, though, a really good example of how these companies are handling it is Google and Gemini. As I mentioned, Gemini is a multimodal approach, and they used videos, a lot of videos, to get stuff in it. They were very careful about not using anything with copyright in any of their training data. They actually had, and I can't really believe they did this, they hired an entire sea of lawyers, probably hired every media lawyer on the planet, to review the videos that were going into this to make sure that they were not using copyrighted works as training data for Gemini. Now, that was exceedingly expensive and slowed things down by a factor of 1,000. But they did it specifically so that they could indemnify companies that use Gemini, because big corporations use Vertex AI and the Gemini models in a lot of their internal products. So that, I think, is the future of where we're going to go. We're going to see the lawyerification of training data coming into all of these new sets of data that are being created. Whenever new data is created, it's going to be tagged. It's going to have in the copyright and all that, whether or not it can be used for training AIs. And we'll still have rogue people using them, just the same way that we have people stealing copyrighted works today, right? That's not going to go away. But what is going to go away is this sort of generalized theft of intellectual property that's being used for this technology that's way out there. And all it's going to take is a couple of multi-$100 million lawsuits, and that's going to shut most of that down immediately. And I see it coming, right? And the companies that played hard and fast and loose with it are going to be the ones at the losing end of that. The companies that didn't will hopefully thrive. I see another question here. What is being done to try to help with the inbreeding that is happening with AI results that are consuming results from other AIs, especially as AI is used more to put out content? Really good question. Yeah, it's the old GIGO factor, right? Garbage in, garbage out. So except in a loop, garbage in, garbage out, garbage over and over and over again. What's being done is they're really looking at limiting the amount of data that's coming in from those sort of like faucet, types of things where they're just throwing stuff at the wall and seeing what sticks. But something you need to think about, which a lot of people don't think about when they look at this issue, if you have an AI generate a thing enough times, the quality will actually go up. Right? So because of back propagation, because of the way that AI actually works mathematically, you will tighten it down. Now, there's local heights and things like that kind of get in the way of this. But a well-written AI, if you do it enough, actually will improve the results. So while in the short term, it kind of goes to hell, potentially using AI to train other AI is not a bad idea. You just have to be a little bit careful with it. And in fact, I have seen projects that use AI to generate code to train other AIs on generating code. And it works because it's able to do it at a quality level that trains the code to actually generate a more generalized code that is then used in, the training model. So yeah, it's fun, but we do have to be very careful because there is a lot of garbage out there. And by the way, never, ever, ever just immediately use whatever you get out of ChatGPT in anything that you're doing business with. Please check it. I don't want to see you on TV, right? Talking about how you had this, law thing that you generated something that was a hallucinations and then you used it in court. Please don't do that.
That has happened already, where a judge, went after a lawyer for bringing up a case that didn't exist that he got off ChatGPT.
Yep.
Well, I don't want to hold you. We've got one last question from Don. He says he works in a nonprofit legal field and managed several national and state-based legal help sites. We're just now looking into AI integration. Any thoughts integrating AI into the legal help sector?
Yeah, I actually, I've had several lawyers talk to me about generating AI-based legal help, and I'll give you the exact same advice that I gave to them, and that is never trust anything that comes out of this that you wouldn't trust your your non-bar lawyers to say to a customer. Meaning, if it's your law secretary or someone who's just an assistant or whatever, like, check your data. Never just have it an open thing where people can just go and grab the data that's being generated by AI, because the likelihood of it being just wrong enough to damage is extremely high. And it doesn't have to be that wrong, right? I mean, law is often kind of vague, right? It's the law until it's not. There's exceptions, and those exceptions can be kind of ephemeral, right? AI is not great yet at seeing those ephemeral gray areas and making a decision that makes sense. Not yet. It's getting better. But again, if you wouldn't trust someone that hasn't like gone to law school and gotten their bar and stuff to answer something, don't trust the system to do it either, because both of those probably will give out the wrong answer an equal number of times. So, but it's great for generating the initial stuff, right? I mean, that's the thing. Check it. You can have it generated. Just have a lawyer look at it and go, "Yep, that's right." Right?
One
and hopefully
thing
they know
that
what they're doing.
it's good for, and I've seen a startup in Michigan that is working with a law startup, is they are able to summarize and they're able to search. And what this company does is they help lawyers prepare their cases. Lawyers sometimes have like millions of pieces of data. They've got to look through emails from 1,000 employees and go through documents, and they'll hire employees like in the Philippines or something just to go through it all. Well, they do a demo, which I've seen live on stage, where they go through all the Enron stuff and lawyers prepare their cases. They have different modes. I mean, some lawyers will use A, B, C, whatever their personality or what they've had success with. you could answer and it would come back right with the stuff that got used in the Enron case. It was spooky good.
Yeah.
And they have
that is one thing that they're very good at. Yeah. In fact, you can even use something that Adobe has with Adobe I/O is the ability to take a number of PDFs and return back what a summary of what's in that PDF, whether it's 100 or 1,000 pages. You can actually return a summary, and it's quite good. No matter what's in the content, it's very good at doing that, right? But it's very good at doing that because you're using your own data as the training source. You know what's in that document, right? A lot of these like ChatGPT things, you have no idea what data it's been trained on. And so you can get back totally random stuff that is just kind of being made up. So, but yeah, that is a really good use of it. I also have a lawyer that's using ChatGPT to write emails to folks that summarize answers to things that they've already written in other things. So like if they wrote a court document and they need to send something over to a client, they can drop the court document into ChatGPT, and it's extremely good at just summarizing what they said in a much shorter amount, which, most people don't want to read 400 lines of stuff. And then boom, they just send it off. It saves them, they were telling me hours and hours and hours every single day, not having to like rewrite it in a more simplistic layperson way. You just have to know the prompting to do that. And that's actually another really important thing I talk about in my talk about prompt engineering and using that properly to create the output that you want from your AI requests.
Okay. Thank you very much, Mark. I don't want to hold you. I guess you've got another meeting in 50 minutes or something you got to get to.
Yeah, so there's I'm an admin for the Sacramento JavaScript Society, and we are having a speaker that's going to tell us about React 19 and all the cool new stuff that's coming. And usually we have about 20 or 30 people. I think we're going to have 60 or 70 coming. So it's going to be kind of wild. This guy's a pretty big deal. He's a GitHub all-star, and yeah, it's going to be fun. But yeah, I'm just sort of there to corral people and make sure they find the place better, and like keep them from trying to get autographs, I guess. I don't know, whatever.
That's one of the cool things. I've been out in the Bay Area a lot, and my sister lives out there, and I go to user group meetings, at least pre-COVID. That's what I like to do. And you get guys that wrote the textbook or do the online course, and they're there, and you can walk up and talk to them. And
that's literally Corbin Crutchley is the speaker. So Corbin just wrote the framework field guide, which teaches you how to write JavaScript in Vue, in React, and in Angular. With all of this, every single example has a version of it in all three different frameworks, and it shows you what the differences are, how they handle things like hooks and all that. It's brilliant. It's a brilliant book. He is just about finished with it. So it's going to be, you can download like a pre-beta of it right now if you want to read it, but it's going to be coming out for free. So if you've ever been interested in learning a new framework, I highly recommend this book. Corbin is a certifiable genius and one of the nicest guys I've ever met also. So, and if you're in Sacramento, which I know all of you are, you should fly out. Randy, hop on a plane.
Hey, I'll be back in the Bay Area sometime in the next couple of years, and I'll see if we can get together.
Yeah.
By the way, next month we have Nolan Eric, who's speaking on Alpine.js, which I'm interested to learn. It's one of the hot new frameworks, and compare it to Vue, which I've done for a couple of years, and it'd take a lot for me to jump, but it's possible, I guess.
You'll love it. It's really amazing. If you liked jQuery back in the day, Alpine is like a modern version of jQuery. It's a simplification. jQuery kind of got overloaded and bulky and all that. Alpine does away with all of that. It doesn't have anything in it that it doesn't need. and it's fantastic. Now, I'm a huge jQuery fan still. I still use it to this day just because it's embedded in my brain. I'm too old to learn new tricks. But Alpine is a really, really neat framework. So you'll love it. And Nolan's a good friend of mine. He actually lives here in town. So he and I,
well,
we get tacos all the time.
Just mentioned, Nick did, that jQuery 4 is out, and that was #1 on Hacker News. So there still are a lot of people interested in it.
Yeah, it's still big. People still use PHP. People still use this crazy thing called ColdFusion.
I know. Imagine that.
I know, right? It's amazing. Someday I'll give a talk on actual ColdFusion at the cool. What's that, Randy?
I thought Rick told me it was dead, like, 10 years ago, then 20 years ago, then 30 years ago. And now, Mark, after your presentation, I have a court case tomorrow. I got to check all the citations and make sure they're really real, before I go to court tomorrow.
You better check it. Yep. Bring receipts.
It's Ruby that's dead now, Randy. That's the big thing.
I know some Ruby developers, so that's why I'm laughing.
Well, that's what they're saying. So,
oh goodness,
every language takes a turn in the barrel.
Yeah, languages never die. Languages never die.
We just hired some COBOL programmers, so still.
Telling you. So I read the other day. I have to go here in a second. I actually read that something like 87% of the of money in the United States runs across COBOL systems. 87% of the finances. It's like trillions of dollars every year. COBOL, right? And COBOL programmers are literally dying because like no people are learning it. Like I'm considering it. Like, did you hire that person for good money? Because I don't know, maybe I need a second job.